I'm Claire Schaefer. This is me. I'm the electrical product manager here at GSC. I am an electrical engineer. I've done both electrical design and some PCB design in my time. Also some IT management, and any of you that know me for a length of time know that electrical puns sort of just happen when I'm around. So I need to come up with a few new ones for this PCB product, but I think we'll be able to handle it. So we're here today to talk about a relatively new piece of software to the SolidWorks portfolio, and that's SolidWorks PCB. And what SolidWorks PCB aims to do is it really aims to bring two worlds together. When you go to create a circuit board, you have to create the physical outline of it. You have to create mounting holes, things like that. And that's often a very, I'll say, rigorous process. And then you also have to create the logical part of the circuit board. You have to create the schematic, the circuit that goes on top of it. You have to create the actual layout itself. So making these two things happen in concert with each other can be quite time consuming, and it often involves a lot of, I'll say, file transfer and a lot of file translation that goes with it. So hopefully none of your desktops look this bad. But a lot of the times when we're working with a couple different teams on the engineering side, in this case it's the electrical team and the electronics team, the mechanical team, we lose what version that we're on. So maybe a mounting hole changed and maybe the electrical person didn't get that update, or they're not working on the latest and greatest board. Maybe something happened on the electrical side, the mechanical team wasn't working on the latest and greatest board. That can very easily happen, and it's very easy to lose your files and then transfer back and forth. All right? So when we talk about that, when we talk about the difficulties, the things that are problems currently in the market today, just the integration. There's no real good way besides the DXF file to get from one discipline to another on the electrical or mechanical side. There's this disconnect between these tools that we have to be able to do this in. They're really great for what they're designed for, but some of the places where they downfall is that communication to, say, the rest of the engineering ecosystem. And as our businesses get bigger, as we become more integrated electronically with our solutions, that becomes a pretty big deal for everybody. 50% of our engineering time is spent trying to figure out which components to use and trying to make sure that our libraries are the way that we need to do. Anybody that's heard me talk about SolidWorks Electrical knows that we talk a lot about libraries and components. And it's the same story, just on a smaller scale, really, with SolidWorks PCB. You need to have the right components, you need to have the right tools and material there for you to be able to work with. And lastly, we did some research, and the average prototype of a moderately complex PCB design is about $9,000. And that's a pretty hefty investment if it ever has to sit on a shelf, if you ever have to do rework on that. That's a lot of money to be throwing around internally, when we could have prevented those design mistakes from happening in the first place. So enter SolidWorks PCB, which is powered by Altium. Everybody hopefully should know who the company Altium is. SolidWorks PCB takes Altium Designer and it puts a different, more SolidWorks feel to it, the interface, but Altium is really the software that's driving that piece of the SolidWorks PCB, excuse me. So today our plan is to run through some PCB design. We're going to talk about this unified design environment that we get with SolidWorks PCB. We're going to talk about some collaboration and the Altium Content Vault. Now, there are a few of you out here that are probably wondering, hey, that's great, but I already have Altium. Excuse me. we have a solution for that, and we'll get into discussing that in just a little bit. There is a connector available that will match the same functionality you'll see here today between SolidWorks PCB and SolidWorks. It'll match that functionality between your native Altium and SolidWorks. So for those of you out there that already have Altium, pretend that when we're working in SolidWorks PCB that we're working in your native Altium. Okay. At the end, there'll be time for questions. So with the SolidWorks PCB, our aim here is to decrease your product development costs, to reduce the risk, and to improve your efficiency to market. And when I say reduce risk, I mean reduce risk of there being errors both to the board electronically and mechanically, and risk that something will happen in time, for a particular deadline. There's all sorts of risks that we're talking or trying to mitigate when we're talking about SolidWorks PCB. So first off, the unified design environment. SolidWorks PCB handles things like schematic capture, PCB layout, 3D library management, some version control, and even some SPICE simulation to the circuits. We don't have to import and export into different programs, and there's no separate pieces, extensions, or any add-ins that you need to buy. When you purchase a seat of SolidWorks PCB, you get everything that is available inside the software. There's no additional modules or anything that you need to buy. You get the whole thing, which is something that being part of the SolidWorks portfolio, their SolidWorks umbrella, does a really nice job of handling that. All right. We talked a little bit about this. I want to mention the Altium Content Vault because it's something that people talk about a lot. You get access to a bunch of different components. The components are updated. There's supplier information, and there's ability to alter something if you need to. What's really unique to SolidWorks PCB is that you are allowed to be connected to these different companies that you see over here on the right-hand side of the screen. DigiKey, Allied, Mouser, Arrow, and have your own particular company log in for those. And from there, inside of SolidWorks PCB, you're able to get the supplier information for that and have that be a part of your schematic. So just one level further, and we'll talk about that when we're working on our schematic. All right, I talked about this before. I always like when I skip my slides ahead. So if you already have Altium, don't worry, we have a solution for you. The SolidWorks PCB connector is what we're going to be talking about, and I'll be sure to highlight its functionality apart from SolidWorks PCB. All right, so you've heard me talk about this piece of software. Let's go ahead and get started. So here's SolidWorks PCB. I have a schematic started, and you saw real quickly that I had a piece, I had the beginning part of a layout started. So just to run through this real quickly, I have a library loaded, and I can have as many different libraries loaded as I need to. I'm going to choose a library that I'd like to use, and that's this particular library. One of the great things that I love about SolidWorks PCB is that the tabs, excuse me, just like they are in SolidWorks or SolidWorks Electrical, are adaptive to the screen that you're in. So if, for instance, you're in the home screen and I'm on a schematic page, I have tools up here that are appropriate for working in a schematic. If I flip over to the board layout side, you'll see that my tools have been replaced with tools appropriate for layout package. Okay, so real nice, real easy. For those of you that are familiar with Altium, just a couple of screens to show you here the things, things that we can do to kind of help you understand. We have an inspector. We're able to see our different projects, project documents, and these are all things that look like, very similar to the way that they look in Altium. And I just wanted to show you that because we get the comment all the time that this is just like Altium with a SolidWorks feel. And it really is, and I really just want to prove that to you here on the front end. And if you have any questions, again, just please go ahead and ask. So we're going to go ahead and add a couple capacitors, and I'm just going to choose the one that I want from my library over here. I'm going to double click, add one here, add another there. I can enter in my ground. And again, I want to enter in some wires. And this is just all typical solution here. So I've entered in a couple new capacitors that were integral to my design. And I want to go ahead and I want to annotate those. If I zoom into those, you'll notice that I don't have the correct tag by them. I don't have a numbered tag. So I want to go ahead and I want to add that. So I'm going to go ahead and choose to annotate my schematic. And what this does is it goes through and it matches everything together. And I want to go ahead and I want to update my changes list. I want to see what changes were made. I'm going to go ahead and then accept these changes. And the nice thing about doing this is it goes ahead and it creates an engineering change order for me, so I can execute those changes. And then if I need to, I can report those changes on a report. Let me zoom in here for you. So be able to see that I created a report for my project. I modified and annotated something of what it was and what it was before and what it is now. Excuse me. All right. So this has many of, I'll say, some PDM-like functionality brought into the software. So now that we made those changes, let's close out of here. You'll see that we've changed values there. Now, earlier you heard me talk about the fact that there is a supplier library that went along with these. So I'm going to click one of these capacitors, and I'm just going to go to the supplier links. And I'm going to ask to add, and it brings in the value for me already, and I'm able to go through and I'm able to search. Now this goes out, and as you see, it'll bring up a bunch of different capacitors. We didn't really constrain this very much, but that's okay. I'm able to see, it looks like we have 4,011. I'm able to see here that we have a bunch of different options that I can choose. The really nice thing about this is that, you know, let's say we pick this particular component here. I'm able to see that let's see where we are. Okay, at DigiKey, there's 1,000 in stock. They're available immediately, and here's my pricing breakdown. How many times, I know this has happened to me in my past, where I go through and I pick a component only to find out that there's either low quantities or there was something else that was cheaper. This is a really nice way where you can design and pick whichever component that you very specifically want, even package size that goes along with that here throughout this menu. So I can enter anything I need to into the keywords, and I can search through all those different suppliers like we had mentioned before. In this area down here, this is where if your company has negotiated prices with any of these vendors, this is where you'll be able to see that. So you'll really be able to get the uptime, the very current pricing for you guys, and the up to the minute quantity. This actually goes out from the website, on the website, and pulls that here. So be able to choose that and go for it. And you'll be able to see here. I'm not going to do it for every component, but I just wanted you to be able to see, you know, what happens when that's there. Okay. So the next thing I want to do is I want to push these changes forward that we made in this. drawing space here in my schematic. Just want to go ahead and save that, and I want to go back to my Home tab. And I'm going to update my PCB. I'll execute those changes. Again, moving over to my PCB, and you'll see here that I have my 2 capacitors that I've added. So you'll see that I get the little bird's nest lines, the little spider webs that come along with it. Right now you'll note that there's a red line kind of snapped to that capacitor. What that means is that it's not necessarily a favorable position for that particular capacitor to be in. And I'm able to move that around the board and be able to see, best placement, things like that for this particular component. All right, I'll do the same thing here with C2. I'll be able to see that here. Perfect. All right, so we've chosen where to place our 2 components, our 2 new components. And I'm just going to go ahead and I'm going to route these. Now, yes, there is an auto router included with SolidWorks PCB, but you don't necessarily need to use that. We can do a bunch of different types of routing here. And again, I'll just go ahead and start. Because I'm live here in a webinar with you guys, I probably won't do this as pretty or take as much time with this as I would typically. But just know that there's a bunch of different types. We can do hug and push. We can stop at the first obstacle. Things like that you're used to seeing in some board design packages are available here. So we'll go ahead and see. We do. And you'll notice that different nets. I believe this is a ground net that we have here. Yep. This ground net here is a little bit wider. We can set that up in our design rules. It's available with SolidWorks PCB. And there we go. So now, these are just nets that we have hanging out here. And if for some reason we see that, like this doesn't look real great to us, I can come in here and I can move this around if I need to. And the software is actually really good about allowing us to do that. And if for some reason I don't like the way that something is, again, I can delete that particular net and have that work wherever I need to. So I'm just go ahead and add my route back in. That's a little bit better. Delete this out of here. There we go. All right, so very easy to maneuver within here. I really like that you can see the nets on all the different traces here throughout this. SolidWorks PCB, just like Altium, makes really light work of being able to do this very easily. So for those of you that are used to seeing Altium, things like we have our layer stack manager. This is the identical window that you would see in Altium, just a little bit different interface. Same thing with our board options and things like that. All right, so I'm going to go ahead and save this. Now that we've added those 2 new items to our board, the model, I'm going to flip over to SolidWorks now. The model of our board that we have is missing those 2 capacitors. You'll see here. So right now I have the circuit board, and it's attached to just a little stepper motor. That's all it is. And I need to add those 2 capacitors here. Now, in the past, I would have to, do some file transferring and some file not transferring. I can't think of the right word. Converting. There we go. File converting to go along with this. So all I need to do inside of SolidWorks PCB And for those of you that have Altium, this will be the same thing. And really this part that I'm going to demonstrate next is a really special thing about SolidWorks PCB. I'm going to flip back real quick to my PowerPoint. So we went through I'll say the electrical CAD side, and now we're at the point where we want to move over to the mechanical side. So this collaboration that I was talking about is a bidirectional link between SolidWorks PCB and SolidWorks, or Altium and SolidWorks. It gives you automated design notification changes. You get a history of comments. You saw a little bit of that before. We can link SolidWorks to our model library folder, so you can start to have more native designs within SolidWorks. The preview animations is something that I think is amazing between the two of them. So if something changes, you can see where it moves. You're able to choose which changes to accept or discard. And then we can embed SolidWorks models and Parasolid directly into our component footprints. So in our library, we can have, now we can have a logical symbol, we can have a footprint symbol, and now we can have a 3D symbol. So we can tie all of those things together to represent one physical part. So let's flip back to my SolidWorks. There we go. So we have this part here. All I want to do within my SolidWorks PCB is I'm going to push, using my connector tool, I'm going to push this information. So I'm going to say added C1 and C2. So I'm going to post this change. Okay. And you can see here that we've, over time, we've had this history, and you can see exactly who has done this. And me, myself, and I only have my computer, so it's done by me and done by my initials. But you'll be able to have as many people as you have access to in your company can have a login to this, so you can actually see exactly who changed what and when as a history on this design. So you'll notice now we see that we have some new changes that have been detected, and it tells the time. And I want to go ahead and I want to view what those changes are. So tell me I added C2. Let me zoom in a little bit so you guys can see that a little bit better. And it's telling me that I added C1. So you can see the little magenta preview here of what two things are going to be added. I actually want to go ahead and do that. So I'm going to check everything. I'm going to accept those changes. So what this does is it pulls information from the library and it brings it forward and actually adds it to the SolidWorks model. Okay. It's a really cool feature. So now let's say that I wanted to, maybe I wanted to, as a mechanical person, change the size of a mounting hole, let's say. So I'll go through and find the mounting hole we want to alter. I want to just want to edit this sketch, and just for demonstration purposes, I'm just going to make this a little bit bigger. Okay, maybe there's some clearance issues, or we needed to add something else to the board, and this mounting hole needed to get bigger. I'm going to go through now that I've edited that sketch. I'm going to go ahead and save. And I'm going to push this information, and I'm going to say changed size of mounting hole. I'm going to post that change back. Go over to my SolidWorks PCB or Altium, depending on what software you have. And I'm going to say, I want to view changes. You see that I have something new here. And you'll see that it shows me that I've changed the size of this mounting hole. So in this instance, I can accept it. But let's say for grins that I really wanted to make everything back to the same size that it was previously. So I'm just going to take this whole size and I'm going to copy it over to everything. Just to bring everything back to standard and just to demonstrate really the connectivity here one more time. Again, I'm going to save this. I'm going to push everything and I'll say return mounting holes to original state. Post this change. Then come back here to my SolidWorks. And I'm able to view those changes. And again, you'll be able to see exactly what's going to change. Go ahead and accept that. There we go. So one of the nice things about SolidWorks, this PCB connector that we're talking about, you'll see here it says SolidWorks PCB add-in. We call it the connector. Is that the workflow with this can be as specific as you need it to be. We have some customers that use this when they create a new project. Instead of it originating, say, on the electronic CAD side part, it originates on the mechanical team. And they'll go through and they'll create a new project for the Ultium team or for the SolidWorks PCB team. They'll create a new board outline, a board shape, and put some mounting holes in it. And they'll push that over to the electronics people. And that way, when they start their design, they already have an outline, a board outline started to be specifically what they wanted to. And it was native to what they're working on. They didn't have to do any file translations or anything like that. All right, so let's flip back over here. So we're done with our design now. We're on time, which is awesome. We know that we have to prepare a design for the manufacturer, and we have to give our board manufacturer a bill of materials, Gerber files, drill files, pick and place, assembly, schematics, all of the, I'll say all of that information that goes together to make that circuit board. So let's go back and talk about what that is. So over here I have my outputs tab, and I can, all of this information here I'm able to print. So pick and place, assembly, a couple different types of Gerbers, the ODB ++ format, which is what we see being pretty much the most common format, drill files and things like that. So if I wanted to print everything, I could print whatever I needed to and go through and do this. And they're created here in our project. And from our project, we can do whatever we need to get that to our board house to get everything manufactured. So just a nice little overview. I always like this to just be able to see what we have, everything going on, this PCB information. Now the cool thing about SolidWorks PCB is that we're able to export the entire board as a parasolid. And you might say, but Claire, you're working in SolidWorks. Why would I ever want to do that? Well, we can export our board in a parasolid, and we can include the copper with that. So for those of you out there on the mechanical side of the house, you're able to run simulations on that copper if it's a heat simulation. And for those of you on the electrical side, if you need to run any RF simulations on this or anything like that, you're able to get the copper out of SolidWorks PCB, which is a unique tool to SolidWorks PCB. All right, so I'm going to wrap up. Get your questions ready. All right, so wrapping up, we've talked about SolidWorks PCB and SolidWorks connector. If you have Ultium, and it's really founded on a proven Ultium technology. Ultium has been out there for a long time, and this is a really very hardy and stable product. the user interface inspired by SolidWorks. Everybody hopefully can see that this is a very SolidWorks and Windows-centric software layout. The integration between the two pieces of software is really the story that we want to tell here with SolidWorks PCB. It's really an unparalleled integration between the two pieces, two sides of the business and two pieces of software. As you saw, the interface between the schematic editing, board layout, and 3D design really happens seamlessly on our system. And those real-time component supplier links are a great thing to have when you're trying to source components for your particular board. And sort of the unprecedented integration of SolidWorks files into your PCB development environment is something that hasn't been able to be done before, and it is currently today. So just to kind of hit this home for you guys, just so you understand, SolidWorks PCB is a complete suite of electronic design tools. So with SolidWorks PCB, when and if you purchase a seat, you'll get SolidWorks PCB, and you'll get the connector that goes with it. Every SolidWorks seat, after SolidWorks 2016 Service Pack 3, has the add-in in it for the SolidWorks side, and what you're basically purchasing is in the SolidWorks PCB case, is the layout tools and the schematic tools with the connector that will connect up to your SolidWorks. So this is the SolidWorks PCB portion is standalone, but it does have that connector into SolidWorks. And then the second tool set is the SolidWorks PCB connector, and that is an add-in for your Altium Designer, and it's basically adding the same functionality that we saw between SolidWorks PCB and SolidWorks, between Altium and SolidWorks, and that you would be purchasing one license for every Altium Designer license that you had to match up to your SolidWorks seats. All right. Okay, who has questions? All right. Give me 1 second here. There's a couple questions here. This is great. So is SolidWorks, the first question is SolidWorks working on integrating into silkscreen? I believe they are, and that can be done, something that's done if you export your board as a parasolid. You can include the silkscreen layer, I believe, on that. So, but I believe they're working on that, yes. Second question says that I am an Altium user for 20 plus years. I want to be able to see the top and bottom copper layers as well as the solder mask openings in the SolidWorks environment. Critical for preventing shorts to housing as well as quantify physical connections to components such as board-mounted coin cell holders. Yep, and that would be something that you would export out as a parasolid then if you needed to have that copper and that information with it, and that's available through SolidWorks PCB. Any more questions out there? All right. Can I use my Altium Vault? Yes, you can use your Altium Vault if you're using Altium. Just make sure that your Altium Vault is version 2.5 or later with that. Forgot to mention that. But I really appreciate everybody here taking the time out of their busy days to spend some time talking about SolidWorks PCB with us. If there's any other questions, please let me know. We'll be following up with everybody just to make sure you don't have any questions or there's not anything else we can do for you. So with that, I'd like to say thank you and have a great day.